Welcome to you all in my YouTube channel Experience Mathematics. In today's video, I am going to teach you how to find out area of the shaded regions bounded by the lines. That means area of the shaded regions in the plane figures. Before starting, I want you to make sure that you please subscribe my channel if you have not already subscribed, so that I will be encouraged to make more videos, and also share it with your friends and press bell icon so that you will be informed about my coming videos. So now I'll start my today's topic. Finding out area of the shaded regions in between plane figures. Let's start. Here in this A number, here is one figure, and here is one shaded region, and we have to find out the area of this shaded region. Okay, so to find out area, if it is possible to complete the rectangle, then it will be quite easy. Okay, so here it is possible to complete the rectangle. We can draw the line parallel to this, passing from this line this way, and we can complete a rectangle. Okay, so now you can name it. You can name it that A, B, this one is C, D, E, F, and here you can name it G. And now here area of shaded region equals to area of rectangle, this large rectangle ABGF minus area of this unshaded rectangle. Okay, from whole rectangle, if you subtract area of unshaded rectangle, then we will get the area of shaded part. Area of rectangle EDCF. Okay, area of rectangle ABGF. Here this is 14 and this is 8. 14 minus 8, this part will be 6 centimeter. So here area of rectangle ABGF will be 14 times 20. 14 times 20 minus area of this rectangle EDCF will be 14 times 6. That will be 280 minus 84. Okay, and if you subtract this much cm square, 80 minus 84, if you subtract this, then 10 minus 4, 6, here will be 7, 9, 17 minus 89, here will be 1, so we will get 196 cm square. It is the required area of the shaded part. Required area. Okay, so our required area is 196 cm square. In this way we can easily find out area of the shaded region. Okay, now let's move to the next question. Okay, in this we have one rectangle and one parallelogram, and in this parallelogram height is given 12, its base is 22. Okay, so its area we can find out by using the formula base times height, and but in this base is not given, but this is the parallelogram, and we know that opposite sides of the parallelogram are equal, so its base will also be 22 centimeter. and base times height, we can find out its area. Okay, so you can also name it here A, B, C, D, E, F. Okay, here A, B, C, D is a parallelogram. Okay, here this ABCD is a parallelogram, as its opposite sides are parallel. Not to be confused with the above one, I will draw the line here. It's a parallelogram, so AB equals to CD, as opposite sides of the parallelogram are as opposite sides of parallelogram. Simply we can represent like this way. Represent parallelogram are equal. Now area of shaded part, the shaded part is the combination of parallelogram and rectangle, is equals to area of parallelogram ABCD plus area of a rectangle EDCF. Now area of the parallelogram formula is base times height, so base is 22 times height is here 12 centimeter given, plus area of the rectangle here, this rectangle's base is CD is also 22 because of the sides are equal, so that is 22 times height is 12. Okay, and now from this both you can take out 22 common, and you will have 282 12 plus 12, so it will be 22 times 24. Okay, and now we can multiply them together. Okay, and while multiplying, here 24 times 2 to the 8 to the 4, 8 4 528 cm square. That is the required area of the shaded part. Okay, this way we can easily find out the area of the shaded part in this case. Okay, now let's move to next question. So in this question also we have combination of two plane figures, one is rectangle and another one is two opposite sides equal, so this is a trapezium. Okay, so we use the formula of the area of rectangle and area of the trapezium and find out the area of the shaded part. Okay, so in this also let's give the name to this. Here we can name this as A, B, C, D, here E, F. Okay, and here area of shaded, okay, I'll draw the line here not to be confused with the above part. Area of shaded region equals to area of rectangle BFEC plus area of trapezium ABCD. Okay, so area of the rectangle formula is length times breadth, so length is 20, breadth is 10, so 20 times 10, plus area of the trapezium formula is half times sum of the parallel sides times height. Okay, so sum of the parallel sides, this is 10, opposite sides of the rectangle are equal, so this is 10, means this BC will also be 10, half times sum of the parallel sides, sum of the bases also we can say. Parallel sides are called bases in trapezium, so this 10 plus 15 plus 15, sum of the parallel sides times height. Height is given 8. Now 20 tens are 200 plus here 1 over 2, 10 plus 15, that will be 25 times 8, 2 4s are 8. Now 200 plus 25 4s are 100 equals to 300 cm square. Therefore, required area required area of the trapezium, required area of the shaded part is 300 cm square. Okay, in this way we can easily find out the required area of the shaded part. Now let's move to next question. Okay, in this we have two triangles, AED and ABD, and from EF is drawn perpendicular to AD, and CG is perpendicular to AD. Okay, this is F point, this is G point, and now we have to find out the area of the shaded part. Okay, so area of the shaded part can be found out by adding this area, okay, and this area plus this area. Okay, like this way we can add together and find out the area of the shaded part. Okay, all right, here area of shaded part equals to area of the shaded part equals to area of a triangle AED plus area of triangle, this AED triangle whole we can find out because this 3 plus this 7 10 and this height is 2. Area of these two triangles area we should find out separately because this height is not given. So area of triangle ABC plus area of triangle CGD. Okay, so area of triangle AED will be half times base is 3 plus 7, it will be 10 times height is 2 centimeter. Okay, and now this plus area of triangle ABC, that is half times base is here this is also given 90 degree. Okay, and here base is 8 times height is 4 plus area of this triangle CGD. Here in this CGD we have to here it is 3 given. Okay, this CG is 3 given, and using Pythagoras theorem. Okay, so let's find out separately on the side. So just opposite to this is H is hypotenuse is 5, and this CG is base, that is 3. Now perpendicular formula is P equals to H square minus B square, that will be 5 square minus 3 square, that gives you 4 answer. Okay, and this GD will be 4. Okay, so here area of the CGD will be half times base, you can suppose this 4 times height as 3. Okay, so in this way we can find out area of the shaded part. Okay, here I have suppose this as b equal to 3. Here base I have supposed 4, so it may be confusion. I will suppose here this p equals to 3 and then b I will write here, so that there will not be any confusion. B equal to h square minus p square. H means 5 square minus p means 3 square, because in right angle triangle anyone as base and anyone as perpendicular we can suppose in two perpendicular sides. Okay, and now 2 can be cancelled, so here will be 10 plus 2 4s are 8, 4 4s are 16 plus 2 2s are 4, that will be 3. Okay, now it will be adding all this together, we will get 32 cm square. Therefore area of shaded part A equals to 32 centimeter square. Answer. Okay, in this way we can easily find out area of the shaded part. Okay, here I think it may be difficulties for you to understand here in this triangle. Here in CGD it is 3, this is 90 degree, this opposite to 90 degree, this CG is hypotenuse, so hypotenuse is 5, and this CG perpendicular we can suppose that is 3, and base this GD we have to find out, b equal to root over h square minus p square, h square 5 square minus p square 3 square, 25 minus 9 16, square root will be 4. Okay, so this we have got 4, and after getting 4 for this area we have found out half times base 4 times height is 3. In that way we have found out, and after calculation at last we have got the area of the shaded part 32 cm square. Okay, so in this way just by using the property of the parallelogram and the formula of the area of the parallelogram, and also the formula of the area of the trapezium, the rectangle, we can easily find out the area bounded by the plane figures. Okay, I hope that you found this video helpful. Thank you for watching, and if you have not already subscribed my channel, please subscribe it right now, and also share it with your friends so that I will be encouraged to make more videos, and also press bell icon so that you will be informed about my coming videos. Okay, thank you very much.